Hi students, here's a spiral review for Spiral 6. We're going to start off with combining functions, which is a graded section this week. We've got some equations, we've got a table, we've got a graph, all the things that you should be pretty used to at this point. First up, we've got m minus 4. That's interesting. I don't think that's supposed to be a 4. I'm pretty sure that's supposed to be an r. So I will make that change before I print this, because I haven't done that yet. So m minus r of 4 means m of 4 minus r of 4. M of 4 is going to be based on the equation. So if we do that, m of 4 is going to be 3 times 4 minus 7, which is 5. And then we've got r of 4, which is based on the graph, and we get r of 4 is equal to 0. 5 minus 0 is going to be 5. All right, 3p of 4 plus 2r of 2. P of 4 is the table. That's going to be negative 2. So 3 times negative 2 for p of 4. And 2, r of 2. R of 2 is going to be 2. That's a height of 2 at that point. That gives me negative 6 plus 4, which is negative 2. Okay, number 4, p inverse of 4. That means I'm looking for where p has a value of 4 and spitting out the answer, or I guess spitting out the input, so it's going to be 2 times 1. And p of 4 is finding where x is 4 and spitting out the output. So minus 2 times negative 2. 2 minus negative 4 is 2 plus 4, which is 6. M inverse of x. So m of x is going to be 3x minus 7. I'm going to rewrite that in terms of x. So we get x is equal to 3y minus 7. Add 7 to both sides, and then divide by 3 to get x plus 7. Divide by 3 is equal to y. That's your inverse function. N inverse of x, again I'm going to start the same way. X is equal to, we got 3 plus the square root of y minus 1. We're going to subtract 3 from both sides. X minus 3 is equal to square root of y minus 1. I'm going to square both sides to get x minus 3 squared is equal to y minus 1, and finally we get y is equal to x minus 3 quantity squared plus 1. Just like last time, there's some reasons that that's not quite accurate, but we're going to kind of ignore that for the purpose of playing with inverses. The inverse of the table, p of x, that's going to switch things around. So we've got x and p inverse of x. And 1, 4 is going to become 4, 1. 2, 2 is going to become 2, 2. 3, 0 is going to become 0, 3. And 4, negative 2 is going to become negative 2 and 4. Next up for transforming functions, this is the first time this has been graded. I'm going to do some videos in both parts, even though I didn't mark them. So describe in words the transformation. Well, x plus 1 is going to be left 1. And minus 2 is going to be down 2. So if I were to sketch a graph, and I'm going to sketch this in red, we'd be going left 1 and down 2 for all these points. So for example, that point would be left 1, down 2. This guy would be left 1, down 2. The end point here would be left 1, down 2. And this end point would be left 1, down 2. Negative r of x plus 3 is going to be left 3 and flip over the x-axis. In other words, a vertical flip. In other words, a vertical stretch with a factor of 1. Do this one in blue. Whole thing's going to be going left 3 and then flipping. That 0 point's going to stay the same, but move left 3. This is going to go left 3, and then instead of having a height of positive 3, it's going to have a height of negative 3. The next vertex point is going to go left 3. Instead of having a height of 2, it's going to have a height of negative 2. Then the last point is going to be 3 over, and instead of having a height of negative 1, it's going to be a positive 1. It would look something like this. So now we're looking at describing something in words, and then kind of moving things around. Okay, first thing I notice is that we're moving 1, 2, 3, 4 units to the right. No matter what happens, I know that's going to be an x minus 4 as part of that. It looks like we're also flipping. And it also looks like this graph is going to be shifting down from where it used to be. The easiest point for us to look at is this vertex, because when I flip this, it's not going to affect the y value. So we're going down 1, 2, 3 points from where it used to be. So it's a vertical flip. It's not stretching. Vertical flip is going to make this a negative f of x minus 4. And again, we're kind of looking at the vertex to help us see how far down it's going. It's going down 1, 2, 3, so it's minus 3 on the outside. Graphing and solving. This has been broken up into 2 pieces just because of fitting things on the pages of your review. First part, we have to do some graphing stuff. I'm going to graph a couple of these. They'll graph a parabola first. I identify the vertexes at 3, 4. All right. And then on either side, because of the number 2 out front, I'm going to go up 2, giving me a sketch of a parabola that looks something like this. The other video, problem is that an absolute value 1, we're going to do a vertex at negative 1, 5. And this has 4 up on both sides. This is a V because it's absolute value. Second part of this section, we got to do some solving. I've got to solve the equation 3 times the absolute value of x minus 1. That absolute value is supposed to be on that side. I'll change that before I print this as well. So we're going to start off by adding 5 to both sides. We get 3 absolute value of x plus 1 is equal to 9. Then divide both sides by 3. We get the absolute value of x plus 1 is equal to 3. I'm going to make this into 2 different equations. The positive version is x plus 1 is equal to 3, which means that x is equal to 2. The negative version is negative x plus 1 is equal to 3. We can divide both sides by that negative to get x plus 1 is equal to negative 3, and when I subtract 1, we get x is equal to negative 4. Those are my 2 answers. You need both of those answers. For the next part, we've got some word problems. We've got an equation in vertex form. And the big goal here is to figure out if we're looking for the vertex, the y-intercept, or the x-intercept as part of this. So for example, for 13, how high off the ground was he when he threw the ball is a y-intercept question. I'm not going to solve that here. I didn't mark this as a video problem, but I wanted to use that as kind of an explanation. For number 14, highest point, that's a vertex question. And I can use the equation because I see the vertex from there. So it's going to be 6 and 12, and that's the time for 6, and that's the height at 12. So the when part would be 6. On the graph, this would have been the vertex. When will it hit the ground? That's going to be an x-intercept question. So in other words, 0 is equal to negative 3. x minus 6 squared plus 12. Minus 12 and divide by negative 3, and I get 4 is equal to x minus 6 squared. If I square root both sides, we're going to have x minus 6 is equal to 2, and x minus 6 is equal to negative 2. And interestingly, let's see if I did some math funny here. We're going to get some interesting things going on here, but that's okay. So interestingly, when we do this, you're going to get that x equals 8 and x equals 4. Both of those are positive, so it would make sense that this thing would hit the ground twice, except that doesn't make sense at all. It's going to come back to the y-intercept question, and what you'd find out is that the y-intercept is well below ground in this case, and that's what I get for trying to choose numbers that come out nice mathematically. How high will the Pokeball be after 5 seconds? That means we're plugging 5 into the equation. So h of 5 is equal to negative 3, 5 minus 6 squared plus 12. 5 minus 6 is negative 1, squared is 1, times negative 3 is negative 3. We'd have 9 meters. And then if we do the same thing for 10 seconds, we're going to have 10 minus 6 is squared plus 12. 10 minus 6 is 4. Squared is going to be 16. Negative 48 plus 12 would be negative 36, which would be 36 meters below ground. Well, we already figured out that we have some things that don't make sense in this problem overall, so maybe Pokeballs can phase and actually go through the ground without stopping. How cool is that? The new section is going to be on factoring and solving. And we've got to do some solving for zeros first. We just did that in the previous section. We just didn't necessarily call it that. So we start with 0 is equal to 2, and then x minus 3 squared minus 5. Oh man, I had it in equals 45 here. Well, that's fun. We're going to change these problems also so that the math comes out the same. The goal here should have been for this to end up being 50 is equal to 2, and then x minus 3 squared. I'm going to zoom in so I can actually make use of my space here. That means that 25 is equal to x minus 3 squared. When I go take the square root of both sides, we're end up with 5 is equal to x minus 3, and negative 5 is equal to x minus 3. That means that x is equal to 8, and x is equal to negative 2. For the second one, we have the same issue going on, which happens. The way that this should have come out is for this to end up being, I don't know. If I add 11 to both sides, I get negative 18. So this should have been plus 18. So 0 is equal to negative 2. X plus 4 squared plus 18. When I subtract that to both sides, minus 18, negative 2, x plus 4 squared. Divide both sides by negative 2, and we end up getting 9 is equal to x plus 4 squared, and I'm realizing as I do this that this was not a video problem in the first place, so, well, there's that. We get 3 is equal to x plus 4, and negative 3 is equal to x plus 4. That leaves us with x equals negative 1 and x equals negative 7. Number 19 is a video problem. This time we are set up correctly. So we're looking for 0 is equal to 3, We got x minus 4 and x plus 5. And I notice that I've got things multiplied together that equal 0, so either x minus 4 is equal to 0, or x plus 5 is equal to 0, or 3 is equal to 0, because that's the third thing being multiplied here. That one doesn't make sense, so we're just going to look at the other ones and get x equals 4 and x equals negative 5. For number 20, we've got 0 is equal to 2x squared minus 7x plus 6. Our first venture into factoring for the spiral. We know we've got to do some a times c stuff, so I got a times c is equal to 12. B is equal to negative 7. I'm going to try to multiply it to 12 and add up to negative 7. Alright, so I know I've got to stick to negative values to get that negative 7. Negative 1, negative 12, no. Negative 2, negative 6, no, that's negative 8. Negative 3, negative 4, that gets me negative 7. So 0 is equal to 2x squared. I'm going to put the even one first. Minus 4x minus 3x plus 6. I'd like you to notice that negative 7 is equal to negative 4 plus negative 3. And then as we head into our grouping, we group our first two pieces together. I can take a 2x out, and I'm left with an x minus 2 on the inside. For my second pieces, I can take a negative 3 out. I always want to take that negative out, and I'm left with an x minus 2 on the inside. I've got x minus 2 in both of these. That forms its own parentheses, and their remainders, or leftovers, 2x minus 3, form our other pieces. This is still equal to 0, so we've got x minus 2 is equal to 0, which means that x equals 2. And we've got 2x minus 3 is equal to 0, which means that x equals 3 divided by 2, or 1.5. For the next part, we've got to factor, find zeros, vertex, intercept, and sketch a graph. This is what we're doing in class when we had third block, and was just kind of the application of factoring. First thing I've got to do is factor this. In this case, a times c, we're looking at 8, and b, we're looking at negative 6. I'm going to multiply to 8 and add up to negative 6. That's not going to be positive, so I'm going to look at negative 1, negative 8, no, negative 2, negative 4, that's a winner. So we get x squared is minus 2x minus 4x and plus 8. First two parts, I get an x and an x minus 2. Then we get a minus 4 and an x minus 2. That gives me x minus 2 and x minus 4 in my equation. That's factored form. Bada bing. Find the zeros. That's the easier part of this. 0 is equal to the factored form x minus 2 and x minus 4. That gives me zeros at x equals 2 and x equals 4. So just in terms of getting my graph going, there's 2, there's 4. Okay, vertex. I know that for the vertex, I'm going to go exactly in between 2 and 4. The number exactly in the middle of 2 and 4 is going to be at x equals 3. And then I'm going to plug this in. I like plugging into the factored form because it comes out kind of nice. And we get y is equal to 3 minus 2 and 3 minus 4, which is 1 times negative 1, which is negative 1. The vertex would be at 3 and negative 1. The y-intercept, I like using the original equation for this. It doesn't matter what you use. So we did factored zeros vertex. And for this, if I plug 0 in for x, we get 0 minus 0 plus 8, which is just 8. You could also have done that in the factored form. and you would have gotten 0 minus 2 times 0 minus 4, which is still equal to 8. So there's my y-intercept. The last thing I need to do is sketch a graph, going through the points that we hit. Hopefully your graph doesn't get all bendy like that. That's it. That's all we got for today's spiral review.